Now we move into learning about functions that can be written as an equation in our two variables of x and y. So we have an input variable and output variable that we learned about before, the x coordinate and the y coordinate. And so when we write these equations that have these two variables, in many ways we can represent these equations as a function. Now it's going to be our job to determine whether they are a function or not. But we have to find a way to graph each individual function, and we'll talk about those in just a second. A couple of important terms that we need to be aware of are that while graphing, we're going to need to plot a certain number of points, and in doing so we're going to need to create a set of points using a table where we will offer the input value or the x value, and then we evaluate the equation with the x value that we've determined. We will get a resulting output value, which would be our y variable. And because of the fact that we're inputting the x value, our y is really dependent upon whatever that x value is. And so we have this codependent relationship here, or excuse me, this dependent relationship here between the x and the y. And so I'm going to go back to our little table that we've been creating. And because the x value really has nothing to do with the y value, we're determining what x value we want to graph. It's really kind of independent. And so we call this an independent variable. And so since the x value is not determined by the y, it's independent. Now on the other side of that equation, however, the y value is extremely dependent on the x value, and so we call it the dependent variable. And so you can see we've created this nice little table that kind of segregates these things into common parts. So we have input values that represent the domain. Those are the x coordinates in a graph, and of course those x coordinates are considered the independent variable. The output values represent the range, which are represented by y coordinates on a graph, and those y coordinates are completely dependent upon the x coordinates. And so we have this nice little table that we can kind of refer back to if we ever get confused when we're being asked for any of these. So let's take a look at how we would determine if these functions, these equations are representing a function or not. If we want to graph any equation and determine whether it's a function or not, all we have to do is create a table of values. And if you recall from Algebra 1, we can create a table of values that's sometimes called a t-chart. And so we construct that table of values by simply creating an x, y, t chart. Now you would provide the x values, and so sometimes we'd say -1 or 0 or 1 or 2 or 3, and you would determine that. And then of course that would give us a resulting y value after I evaluate the x values in the given equation. And so this is going to give us a set of xy ordered pairs that we can graph. Now we want to connect these xy ordered pairs when we finish graphing them to see what type of function it's actually going to create. But we'll get to the different types of functions in a later lesson. So let's see how this would play out in a given example. And so sample problem 3, we give you two functions to graph. In the first function, in part A, y equals x plus 1, we've given you basically a t-chart there to use, and for part B we've given you a second t-chart. Now keep in mind you're going to create the x values for these and determine the y values by plugging in the numbers to the given equation, and that plugging in of numbers, if you recall, is called evaluation. So go ahead and pause the video and see if you can draw off of your Algebra 1 skills to graph these two functions. Okay, so I'm going to do part A first. As a general rule of thumb, I would like to get x values that are on either side of the axis, and so I'm going to use a -1, a 0, and a 1 to create these points. Now, what I need to do here is I need to actually take the -1 and plug it in for x, or evaluate that equation with x equaling to -1. And so what that's going to look like is x equals to -1, so I'm going to say y equals, and I'm going to substitute that in there. And so y is going to simply equal to 0 when x equals to -1. If I did the same thing again, except this time using a 0 for x, I'm going to get 1. And then one last time, I'm going to do 1 and for x, and y would equal to 2. And each of those represents a point on the coordinate plane. So I'm going to do -1, 0, 0, 1, and 1, 2. And now I have this pattern of lines that I want to use. And so this pattern is going to give me the opportunity to draw the given function. Now, when I draw this given function, I want to draw it as best I can. In this case, you can notice that the pattern is actually being represented by a straight line, and so I'm going to simply try to connect these as best I can. And so sometimes you just need to grab your ID or some sort of can't seem to do that very well. I'll just have to freehand it right now. So we'll just draw that as best we can. I apologize for how sloppy that looks, but basically you can see that we have a line going through those given 3 points. And so if you recall from Algebra 1, when you learned how to graph lines, that's basically how you would do it. Now, if you have any function given to you, you can plot x, y points in a table like this and graph any function that's given to you. So it doesn't require you to have any kind of fancy tricks. A t-chart table of points would be just fine. And so I'm going to do part B in a different color. And so when I'm going to do this one more in my head, so when I plug -1 in for x, I'm going to get a -3, and then -4 is going to give me -4. When I plug 0 in, I'm going to have -1, and when I plug 1 in, that's going to give me a result of 2. And I'm going to try to plot those points. -1, -4, 0, -1, and 1, 2. And you can see that these have a common point. And again, I'm going to recommend that you use a straight edge of some sort just to keep the graph looking halfway decent. Now, if you want to check yourself, you can always graph these in your TI Nspire calculator to verify that you plotted the points correctly. So let's take a look at one more example here. Part C. So in part C, we have another function that we want you to graph, and so we need to simply make our own set of points for this function. So go ahead and take a few seconds to fill in a table of points and graph those. Okay, again, I'm going to use the simple points -1, 0, and 1. You could choose any x value that you wanted. So when I plug in -1 in for x, I'm going to end up getting -2 plus 1, which is going to give me a -1. If I plug in 0, I'm going to be left with 1, and the last one is going to give me 3. And so those are my given points: -1, -1, 0, 1, and 1, and 3. And I'm just going to simply draw the best line I can through those given points. Okay, that's a quick introduction to graphing functions. Whether they're lines or something else, you can always use a t-chart or a table of points to graph the function.